Alright.
So today we're gonna look at the practice test. And work through that, and we're doing, and the test is gonna be next Tuesday in class. And as I'm recording this, I also plan to put this into Canvas, which I'll probably do tomorrow morning. I am off tomorrow from any work, so I have a 3-day weekend. Just hope I feel better. I got sick again, and the ironic part was I was supposed to be off for jury duty, and I asked for permission to put the classes online because of the jury duty. Because I was afraid I would get out of jury duty so late that I wouldn't be able to make the class here on time. So anyway, jury duty ended up getting canceled, and then I got sick. I actually woke up in the middle of the night last night, hallucinated that there were people in the room. So very strange hallucinations I had. And that comes from kind of fever. So hopefully by Tuesday I'll be okay. It's I think it's just a run-of-the-mill cold. Yeah, there would be like 9 questions on the test also. They're not going to be like example to be of a similar flavor. So it's not going to be like the same questions, different numbers. Similar questions. That's what I'll say about that. It is currently 4 o'clock. Okay, we have another minute for other people to join. Currently have 11 people here. I got 13 people here. So I believe everyone has this available in Canvas. So we actually have this, of course, on the actual test itself. There'll be ample space. I probably like no more than 2 questions per page for you to include your work, unless it's not a lot of work for the question involved here. Okay, so let's go ahead and let's take a look at how these problems are done. Probably once I'm done with these, whenever we finish up, I'll probably go ahead and call it a day. This is being recorded and will be uploaded into Canvas. Maybe I'll even try to get it uploaded to Canvas between my lessons tonight. We'll see. So I'm going to take this off here, and I'm going to bring the questions to the page. What you should have, what those are. I think my daughter has added her also contributions to my pad here. All right. And we'll get started with question 1. Question 1 says, is here. If we have f of x equals 6x to the negative 2 plus 8x to the third plus 11x, it wants to find what f prime of x is. Okay, now this one can be a little tricky. When you're working with negative exponents, but if you want to find the derivative of this question, remember you have to bring this down. So it's gonna be negative 2 times 6. That'll be negative 12. I subtract 1 from negative 2, and then when I subtract 1 from negative 2, that's going to give me x to the negative 3. 3 times 8, that's going to give me 24 x squared plus 11. So I would accept it in this form. I mean, if you were to also write another form of, let's say, negative 12 over x to the third plus 24 x squared plus 11, I would certainly accept that form for that answer. So hold on, someone is unmuted. Okay. Any questions on number 1 here? I'm going through the list to see if anyone else is unmuted here. Okay. Yeah, a couple of people not muted. If you got a question, please feel free to unmute yourself. So if I muted you inadvertently, my apologies. Please do feel free to ask questions if you have them. Just I know random noises are going to occur. But when you have 17 people in the chat, that can be a lot of random noises if we're not careful. So okay, so it says 1 hour, this is question 2 now. 1 hour after X milligrams of a particular drug are given to a person, the change in body temperature T in degrees Fahrenheit is given by T is equal to quantity of X squared times 1 minus X over 8, where the interval of X is from 0 to 3. Approximate the changes in body temperature produced by changing the drug dosage from 1 to 1.8 milligrams. Okay. So the X, keep in mind here. So what they're saying by giving this, let me kind of show this here. We're saying that this formula will to change a body temperature, but that's only true if the dosage is between 0 to 3 milligrams. My guess that might be like a safety concern. The body can probably not process more, or it may not follow this formula if we don't do that. So it says approximate the change. Now, so when they talk about change, this is where you're thinking like derivative. Okay. Now, there's a couple ways to find the derivative of this. You can, if you want to, like use the use the product rule for something like this. Let me go and write that down. It says approximate the changes in body temperature produced by changing the drug dosage from 1 to 1.8. It says round to the nearest hundredth when necessary. So let's go and take a look at this. So we have T equals X squared times 1 minus X over 8. Don't worry about the interval because they give us from 1 to 1.8. And we're looking for the change in the drug dosage. Hold on. It's body temperature. Hold on. I want to see this. Oh, okay. You know what I'm thinking for this one here? It says 1 hour X milligrams to a particular drug are given to a person. Change in body temperature. Okay. So this formula is for the change in body temperature. Approximately the changes of body temperature produced when you increase this from 1 to 1.8. So I think what they're looking for us to do is actually to let let X equal 1. They're looking for X equal to 1.8 and then to compare the difference of those results. So that's what we're going to do. They're actually not looking for us to do the derivative of this. They're actually looking us to put in 1, put in 1.8, and then see what the difference is. I believe that's what they're asking us to do. So let's go ahead and put this in. Hold on, let me take a look here. Okay. All right. So that's going to give me then 1 squared times 1 minus 1 over 8. So this is going to give us 1 times 1 minus 1 over 8. That's going to be 7 over 8. That equals 7 over 8. Well, let's see what it is at when we have X equal to 1.8. So that's going to give us 1.8 squared times 1 minus 1.8 over 8. Okay, a little more of a cumbersome calculation, much nicer when you have just the 1 there. So cranking that out. No. So this part's going to be 3.24 times 1. This would be let's see, 1.8 divided by 8. That's going to be 1 minus 0.225. So this is going to be 3.24 times 0.775. I multiply that together. And this one turns out to be 2.511. So here I get 2.511 change in body temperature. Here I only get 7/8. So if we want to know that, like at 1 milligram, it's only 7/8, which is going to be equal to 0.875. So if I take 2.511 and I subtract 0.875 from that, that difference produced is going to be 1.636. I don't think. Yeah, I don't have the answer key in front of me for that, but if you have the answer key in front of you, I mean, I could dig it up, but if someone could kind of look that up quickly, make sure that is the correct answer that they're going after, that would be appreciated. Hold on. I have it here. Oops. Okay, so I'm looking on the answer key here. They have 1.3. It's a slight difference from what I have. So I may want to come back to this question in a little bit. And if someone, or maybe what I want to do is, I don't know, take the derivative of this perhaps, but I thought what I was doing is correct. If someone sees some type of error in my math, possibly, like, don't be afraid to point that out to me. I am not 100%. Interesting that the topic of lowering temperatures comes up because I took some Tylenol recently. I've been working on a fever right now, so I might make a few errors here, but hopefully I'll be not too error prone. I'll come back and take a look at this question once we're done to see if I can find something. If one of you find how to get to the answer to this also, I would appreciate knowing what you do with that one. Okay, let's take a look at number 3. It says a single bacterium divides every 0.5 hours, every 30 minutes, to provide 2 complete bacteria. So if we start with a colony of 6,000 bacteria, after T hours, there will be, then the function is ACE of T equals 6,000, because remember that's going to be the starting number, then 2 to the 2T. Oh, I see. And then they go ahead and write this as, this is equal to 6,000 times 4 to the T, because they take 2 squared. So the ACE of T is equal to 6,000 times 4 to the T. Okay. Find A prime of T and then A prime of 1. Okay. So, so this one, I mean, if you use a product rule on this, which you could do, then you're going to have like one of those terms drop out because the derivative of 6,000 is 0. So what we're going to do is we're just going to bring 6,000 along, and then we're going to take the derivative of this. Okay, and what the derivative of this is going to be, if we have 4 to the T, let's just say that equals y, just this portion here, y prime, that's going to equal 4 to the T times ln of T. Okay, that goes back to one of the old derivative rules I think we learned back, probably for test 2, and it's not one that we see commonly, but it is one you should be familiar with. So it's going to be 4 to the T times ln T. So that means A prime of T is going to be equal to 6,000 times 4 to the T times ln T. Any questions about how I came up with that derivative? So make sure you're familiar with this rule. It is a more obscure rule of calculus, not one that comes up frequently, but it's one I've seen in this book with a more commonly than with other calculus books usually. So if I want A prime of 1, that's going to equal 6,000 times 4 to the 1 times the ln of 1. Fortunately, the calculation to this one is hold on, let me see here. Guys, one thing I made a little mistake here. I don't know if anyone caught this. It's not the ln of t, it's the ln of 4. This is the ln of 4 here. So I was looking at this and wait a minute, I did something wrong. This is the ln of 4. So the derivative of this is not going to be 4 to the t times the ln of t. It's going to be 4 to the t times the ln of 4. So yeah, please correct that mistake in your notes here, please. So if we have y equals 4 to the t, the derivative will be 4 to the t times the ln of 4, not the ln of t. Okay. So this is going to be the ln of 4. So 6,000 times 4 to the 1 times the ln of 4. 4 to the 1 is going to equal 4 times the ln of 4. And once you figure that out, that's going to equal about 33,271. And you want to round this to the nearest whole number, 3,271 bacteria. If you're using a more crude calculator, you want to find the ln of 4 first, then multiply by 4, then multiply by 6,000. Sometimes it may be difficult if you're using a calculator, you can't put this in all at once. It's hard to find the ln of 4 on its own with all this work going in. But if you find the ln of 4 first and then multiply it by 24,000, you can get this result here. Any questions on how we did number 3? Okay. Let's take a look at number 4 then. So here we're told to find if we're given the function f of x equals 3x minus 4 times 4x to the third minus x squared plus 1. We're told to find f prime of x. All right, so when you do a question like this, you don't have to do the work to the side necessarily. But if you do make a mistake, where if you try to do this in your head, it does enable me to give like more credit when you make a mistake. So you don't have to, but I would probably encourage it unless you feel really strong about your abilities here. So we're going to say that f is going to equal 3x plus 4. F prime will equal 3. G will equal 4x to the third minus x squared plus 1. G prime, watch my math, guys. This is going to be equal to 12x squared minus 2x. And remember, this is going to be f prime g times, I would say, g prime f. So this is going to be equal to 3 times 4x to the third minus x squared plus 1 times fg prime. So it's going to be this binomial times this binomial plus 3x plus 4 times 12x squared minus 2x. All right, so guys, you're looking at this with independent eyes. Before I go on, can I get thumbs up from people if the work looks good and correct so far? Or if I made a mistake, this would be the time to catch me, please, before I take this question further. Okay, thank you, Diego. Appreciate you. Can I get approval from maybe a couple of the students here? Okay, thank you, Jenny. All right, so so first off, I'm going to do this. Let me bring the f prime of x over here. I multiply 3 through this. That'll be 12x to the third minus 3x squared plus 3. Now we've got these two binomials are going to multiply together. I'm going to do this work off to the side too. This would be 12x squared minus 2x, 3x plus 4. So this is going to be 36x to the third. This will be negative 6x. 12 times 4 is 48x squared. Oh, this is x squared over here. 3x times negative 2x is negative 6x squared. And then negative 2x times 4 is going to be negative 8x. And I'm just looking at my work on the screen here just to make sure I have everything correct. Okay, it all looks good to me. Anyone wants to give me a thumbs up on that in terms of how we multiply these two binomials together? I think we're good. Alright, so what I'll do is I'll just do the consolidation of the work. Thank you again, Diego. I'm gonna consolidate here. Like I can't do much with 36x to the third, at least not yet. So I'll put 36x to the third here. Let's just consolidate 48 and then negative 6x squared. That'll be plus 42x squared and then minus 8x. So I can do that work down here. Now I do have some like terms to combine here also. 12x to the third plus 36x to the third. That's going to be 48x to the third. I have 42x squared minus 3x squared. That's going to be plus 39x to the second. And then believe. Oh yeah, there's a negative 8x and this is plus 3. Okay, so these don't combine, so we just got to put these on as negative 8x and plus 3. Okay, I'm looking. So we're going to be keeping an eye on because I want to make sure I do this right. I'm looking at the answer key for this. It's telling me I did something wrong. Let me take a look at the problem. Hold on, no, that's fine. I thought I wrote the problem down wrong, but I wrote it down correctly. I think the answer key is wrong on this one. How many people, you all see the work on this. How many people agree with my answer on question 4? I'm looking for a thumbs up if you agree with the answer. I'm gonna stop sharing for a second. I'm being just sensitive to how I feel today because I'm not 100%. Is there? Oh, hold on. 3x. Okay. So, okay, so someone else, I guess, has found. Okay, looks like someone found a mistake. All right, yeah. So, to those who are messaging me, especially direct messaging me, yeah, I did make a mistake on this one. So let me go back, and it looks like someone else found the mistake I made in question 2 as well. All right, so hang on, let me go back and share my camera on this one. Yeah, here I should have 3x minus 4. Okay, that should be a minus 4, and that's going to have an impact on the answer. So if I have minus 4 here, that's just going to switch the signs, and this is going to be negative 48x squared. That's going to be plus 8x. Okay, so I wrote f prime of x. I'll come back to the second question in a moment. This should still be 12x to the third minus 3x squared plus 3. Let's combine like terms now. So this is going to give me, this is still plus 36x to the third, negative 48, negative 6. That's going to combine to be negative 54 x squared, and then this will be plus 8x. Okay, so yeah, this is going to explain the difference in the answer key. Thank you for catching those mistakes on this. Yeah, guys, please don't be afraid to tell me if I'm doing something wrong. Like I said, I'm not 100%, so I thank you for your vigilance on here. So let's go back and put this to, hold on, did I write all this down? Yes, I did. Okay, so we have here for f prime of x equals 12x to the third, negative 3x squared minus 54x squared is going to be negative 57x squared. Then this will be plus 8x plus 3. And that looks to be the correct answer to question number 4. Any questions on how that was done? Okay, so I'm gonna put count here. Oh, so apparently, someone who said they found the mistake for number two actually said, no, I did it correct for number two. So sometimes, I mean, not in this case in particular, but sometimes, the answers provided in the problems are, um, um, or not correct. Once in a while, you do find a mistake in the answer key. But what I'll do is I'll look at the test, and if there is a difference in the answer that I obtain in the answer key, I will specify the method for what I want you to do for that question. Like I'll do it the day of the test. Okay. So otherwise, I don't want you worrying about you applying the wrong method to it. Okay. So in terms of a question like number two, I believe I applied that question directly because that equation they provided did give the changes. It's not like the equation gave the total amount. It should be correct, but I'll specify that in case when I do the question, if it differs from the expecting answer I'm expecting to get. All right, let's go ahead and try number 5. Keep an eye out because we're going to be doing some math here where it can be easy to miss a little thing like a plus and a minus. All right, so we want to find if we have the function y equals x squared minus 3x plus 2 over x to the 7th minus 2. I want to find dy dx. That being the derivative. So I'm going to define f here as x squared minus 3x minus 2. G will equal 2x minus 3. Oh, sorry. F prime. And guys, it's an early day. I'm going to work till about 9:45 tonight. So I hope I make it. Get some water quick. So G is equal to x to the 7th minus 2. G prime, that'll equal 7x to the 6th. So if G is equal to x to the 7th minus 2, G prime is equal to 7x minus 6. One more thing we got to find. G squared, that's going to equal just x to the 7th minus 2 squared. So I'm just going to write it like that. I'm not going to try to FOIL it or anything like that. Okay. So remember, this is going to be f prime g minus g prime f. Okay. I don't think I'm going to actually move it down a little bit because I don't think I'm going to be able to fit everything across here. So I'm going to write dy dx equals, well, let's see, f prime, that's 2x minus 3 times x to the 7th minus 2 minus the quantity of g prime, that's going to be 7x to the 6th times f, which is x squared minus 3x minus 2. Yeah, see, this gets pretty long once you put everything down, especially if you want to show nicely. And then this is going to be divided by the quantity of x to the 7th minus 2 squared. Questions on what I've done so far, and any possible, see, I look what I did again here. Just I'm looking over everything. I wrote this as a plus. I wrote this as a minus at first when I should have wrote it as a plus. So yeah, guys, be careful of my work. And then the consequence of that, it hasn't impacted anything else yet. So fortunately, I caught it early. Please take a look and make sure everything looks okay. And give me a thumbs up if you clear that. Okay. All right, we're going to proceed forward then. So dy over dx. Let me go ahead and multiply. I'll multiply this up here. I've got some space. Why not? So I have 2x minus 3, x to the 7th minus 2. So 2x times x to the 7th is going to be 2x to the 8th. 2x times negative 2 is going to be negative 4x. Negative 3 times x to the 7th is going to be negative 3x to the 7th. Then negative 3 times negative 2 is going to be plus 6. Nothing combines. We're just going to put that as is. So for the first part here, I'm going to put, let's see, 2x to the 8th minus 3x to the 7th minus 4x plus 6. Now, actually, I could probably just distribute this as a negative 7 through. Yeah, I could just do this. So let me get rid of that. Negative 7 times 1 is going to be negative 7, x to the 6 times x to the 2nd. So there'll be negative 7, x to the 8th. Negative 7 times negative 3 is plus 21. X to the 6th times x is going to be x to the 7th. Negative 7 times 2, that's going to be negative 14, x to the 6th. And again, all this is still over x to the 7th minus 2 squared. All right, and then if I want to clean up the top a little bit here. 2x to the 8th minus 7x to the 8th, that should be equal to negative 5x to the 8th. Negative 3x to the 7th plus 21x to the 7th, that's going to be plus 18x to the 7th. Next, I've got negative 14 x to the 6th. Then I got minus 4x plus 6. I mean, just checking this out. Yeah, looks good. And then this is all going to be divided by x to the 7th minus 2 squared. And that's going to be the final answer for question 5. Any questions about how I obtained that result? And again, guys, whether you want to, you can send me a question privately, especially if you think I made a mistake. Okay. I caught myself in a mistake. Someone else has already caught me in a mistake. So. Okay. If I see a question come in the meantime, I'll come back to it. Take a look at a few methods for number 6, depending on what you're comfortable with. So if we're given y equals 5t squared minus 4t to the 2nd, it wants us to find dy dt. And there's a couple ways you could do a question like this. Oh, and this is all in parentheses here. Okay. So one thing you could do is you could apply the chain rule, which is a rule we've learned, where we're gonna multiply this whole thing by 2. So it's gonna equal 2 times the quantity of 5t squared minus 4t. And that'll be raised to the 1. So it's just like that kind of disappears. Then times the derivative of what's on the inside there, which would be 2 times 5t is 10t minus 4. So that's something you could do. And in fact, if you just leave the answer like that, you know, that's kind of the expectation of what you'd would do for the question. You don't even need a 1 here. It doesn't have to be shown because that's kind of a implied if there's not an exponent there that it's 1. So this is the derivative. The other thing you could do to find an equivalent form, although I don't recommend it. You could square the quantity of 5t squared minus 4t. Like you can multiply it by itself and then just take the derivative of that. It would look like a very different answer. It would look very different than this, but it would be an answer that would be an equivalent form. It would be the same kind of answer that you would get if you take 2, multiply it through this, and then you multiply the resulting binomial by this binomial. So is there anyone who would like to see the other approach to doing this? If so, can you just raise your hand, please? I'll stop sharing in a second. Anyway, let's see the other approach to this, or is everyone okay with the chain rule? You can multiply, well, the 2 is already out here, but you don't have to worry about the exponent anymore because we've addressed it. So that's why we just take the derivative of the inside. So it's 2 times 5, which give me 10t, and then the derivative of negative 4t is going to be negative 4. You can I think I know what you're asking now. You multiply 2 through this. You don't have to keep multiplying 2 through this and this. Just multiply 2 by the first part. That's it. So I'm seeing another question. Can also be written as 20 minus. Hold on here. Oh, so if I distribute the 2, hold on. 2 times this is going to be 10t squared minus 8t. Okay. Hold on. I'm looking at the second. 2 times this. That's 1. Okay. So what I think a few of you are doing out there, you're taking the 2 and multiplying it by 10 in this. So that would give you 20t minus 8. And then that would be multiplied by 5t squared minus 4t. So if you do that, okay, let's say you decide to multiply the 2 through this. Now I'm answering questions that were sent directly to me. If for some reason you just chose to multiply the 2 through this part and not this, the way you'd have to write that would be 5t squared minus 4t times 10t minus 8. You'd have to have parentheses around this quantity and this quantity. If you didn't have parentheses around that, that would be incorrect. Okay. So I guess thought most people would be inclined to multiply the 2 through this, not the second part. I mean, you can multiply through the second part, but it's next to, it's next to that first binomial. For the people that are messaging me privately, does that answer your question? Very good. All right, so any other questions on number 6 here? All right, let's take a look at number 7 then. Number says, find the critical values and determine the intervals for which f of x is increasing and the intervals where f of x is decreasing in this function here. Okay, let's go ahead and find those. So we have f of x equals x to the third plus 3x squared minus 24x plus 6. Okay. So, hold on. Sorry. I wasn't measuring my screen here. Here we go. Well, it means f prime of x, that's going to equal 3x squared plus 6x minus 24. Now, if I want to find those critical values, okay, what I'm going to do now is I'm going to set, okay, so for the critical values, I'm going to set f prime of x equal to 0. Okay, so I'm going to get 0 is equal to 3x squared plus 6x minus 24. And then what's going to happen is, first off, to try to solve this equation, I'm going to go ahead and factor a 3 out. So 0 is going to equal 3 times x squared plus 2x minus 8. Yeah, that's all right. First, I wasn't liking the numbers, but I didn't think it through. Then if I divide by 3, I get 0 is going to equal x squared plus 2x minus 8. And when I factor this, I'm going to get x. Two numbers that multiply to -8, but add to 2. That's going to be plus 4 and then minus 2. And I'm going to set each of these factors equal to 0. Okay, so my critical values, where this graph is either going to top off or bottom off, is going to be -4 and 2. Okay, now to determine, so let's find the critical values to determine the intervals where f of x is increasing and the intervals where it's decreasing to the function. All right. So let's run a first derivative test now. And this is going to be, hold on here. And I have -4. I have the value of 2. Now I need to pick some values in between. I'm going to put those below. Value less than -4, I'll just choose -5. Value between -4 and +2. If you get like a positive number and negative number, always go with 0. That's going to give you the fastest results, absolutely. And then here, a value greater than 2, which is going to be 3. We're going to stick each of these values into the first derivative. We don't necessarily care about the value of the first derivative. We just want to know, is it positive or is it negative? If it's negative, that means the function is decreasing. If it's positive, it means the function is increasing. All right, so what I'll do then, let me skip a few lines here because I want to try to draw the graph in relation to here. So I want f prime of -5. So I'm going to go with the original function. That's going to be right here. It's going to be 3 times -5 squared plus 6 times -5 minus 24. So -5 squared. Now you can put this in your calculators, and most people have calculators for this. This is going to be -75. This is going to be -30. This is going to be -24. This is clearly going to be negative. So this function is most definitely decreasing all the way down to -4. What's it doing at 0 though? So let's try f prime of 0. Again, lowest I didn't like, if you calculate this will go to like, I think -129, but I'm not concerned about the value, just the sign. It's negative. That's what my concern is. Hold on here. Oh, guys, wait. Did anyone make a comment on this? Because I caught myself in a big mistake here. Anyone? No one caught me. Okay. No, I'll tell you the mistake I made. Let me go back to the screen here. When I square -5, that's going to be +25, and +25 times 3 is 75. That's going to be +75. 75 minus 30 is going to be 40. 40 minus 24 is still going to be +16. So this is actually going to be plus. So this function is going to be increasing on this interval. Let's see what happens when we put f prime of x equal to 0. So this is increasing because that's the first derivative is positive there. So if I put this in now, that's going to be 3 times 0 squared plus 6 times 0 minus 24. Well, this will turn out to be 0. 0 minus 24. That's going to be negative here. So everywhere between -4 and +2, the function is going to be decreasing. What happens after we pass 2? What happens with 3? So for that, find f prime of 3. Let's see, that's going to give me 3 times 3 squared plus 6 times 3 minus 24. This would be 9 times 3, that's 27. Plus 6 times 3 is 18 minus 24. So 27 plus 18, that's going to be 45. 45 minus 24. That's 45 minus 24, this should be 21. Either way, it's positive. So here the function is going to be increasing. So what's happening at like these critical values here, if you will? Okay, I just want to kind of graph this out. So here, function's increasing, then it begins to go down, then at 2, it begins to increase again. So we're saying, because this is positive, the function is going to increase until it gets to -4. We're going to have, in this case, this is going to represent a max, a local. Oh, you guys call it a local max. Your books refer to this as a local max. Over here, the function is decreasing from -4 to 2. It bottoms out and then begins to increase again. So this part here is going to be a local min. So what are these intervals that they're referring to in terms of where it's increasing? Okay, so where is it increasing? Let's put this down here. It's increasing from -infinity to -4. Oops, to -4. And then it's also increasing on the interval of 2 to infinity. Notice here, I'm not putting any brackets because at the value of like -4 and at the value of 2, at those values, the slope is 0. So it's not increasing or decreasing at those points. Where is it decreasing? Excuse me. Where's it decreasing? On the interval between -4 and 2. Now, understandably, not all these questions are going to be weighted the same. A question like this is going to be weighted a bit more than other questions. So it won't be like every question. If there's 9 questions, not every question will be worth 11 points. Some questions you get the derivative pretty straightforward. Some questions like this are more work. This question may be worth like 16 points, for example. I was looking for all the steps needed to show this. So no, a fair amount of work. So on a question like this, I would probably give, maybe close to a full page because of the amount of work that has to be shown. Any questions on number 7? Okay. All right, let's try number 8. And so it says here, determine the intervals over which the function f of x x minus 4, that quantity cubed, is concaved downward. Okay, so let's take a look at this then. So we're given the function f of x, and this equals x minus 4 to the third. So if we want to know where it's concave downward, we need the second derivative of this. Okay, and then well, let's go ahead and take a look at this. So I'm going to find the first derivative of this, and we're going to use the product rule for that again. But the product rule is going to kind of simplify pretty quick on this one. This is going to give me 3 times x minus 4 squared, and then the derivative of the inside is just 1. So when I take the derivative of that, you could show that, and then you just say that f prime of x is going to equal 3 times x minus 4 squared. Keep it this way. That's my humble recommendation. Let's see what happens when we take the second derivative down. So we get f double prime of x. We get 2 times 3, that's going to be 6 times x minus 4. And that's going to be the first derivative. That is still 1. So we have this now as our second derivative. So what we can do in terms of the second derivative is we can just go ahead and distribute. I mean, I want to. No, I don't think you want to distribute on this one. I don't think we have to distribute on this one actually. I'm going to leave it like this. This is the second derivative. So if I want to find the intervals where this is concave up or concave down, what I'm going to do now for my critical values, I'll put CV. I want to set f double prime of x equal to 0. All right. So if I have 0 is equal to 6 times x minus 4. Well, the reason I said is because usually that I said not to distribute 6, usually a strategy is to like factor it, and then let's just divide by 6. Then we get 0 is equal to x, x minus 4. And if I add 4, I get 4 is equal to x. So in terms of looking for concavity, that's the point we're looking for. That's going to be that value of x equals 4 is going to be where a point of inflection takes place. So this is going to be a point of inflection. Now, of course, for the point itself, we need the value of x and y. But I know that where x is equal to 4, there's going to occur a point of inflection. So for this now, what I'm going to do is I'm going to run the second derivative test. And let's see here. All right, so I'm gonna, my critical value is 4. I'm gonna put this on top, and I want to pick a value less than 4, pick a value greater than 4. Probably for that one, I'm just gonna pick 0. For that one, I'm gonna go ahead and pick 5. I can pick 6 also, not a big deal. And then I'm gonna skip a little space here, and I want to find f double prime of 0. And I'm going to put that into the second derivative here. So it's going to be equal to 6 times 0 minus 4. That's going to give me 6 times negative 4. That's going to equal negative 24. So it looks like on the interval of negative infinity to 4, it's going to be concave down. But let's try 5, put that in and see if we get a positive result now. So f double prime of 5. That's going to equal 6 times 5 minus 4. And that's going to give me 6 times 1, which will give me 6. Important thing, it's positive. On the interval of 4 to infinity, it's going to be concave up. Okay. So what happens on a graph like this is probably happening as probably doing something like this, then it begins to switch concavity. So it's something like this, where it's going to be concave down through here. Then once it gets here, the concavity switches upward, and then it goes up further like this. Because this is the graph of like x minus 4 to the third. So we expected the graph that kind of looks like this. And let's read what the question is asking again, just to make sure. Determine the intervals on which is concave downward. So the interval that is concave downward is going to be from negative infinity to 4. And that is the answer to question 8. Any questions about that? All right, so one thing I have not done yet, guys, and there's just certain things I was planning to do until I started hallucinating at people in my room last night from my fever, was to move up your dates. So that's one of the things that I have on my agenda to do this weekend. I will do it when hopefully I am feeling better. And I also, and then I've got some old quizzes here I need to grade and everything too, and a few tests. So I have 3 days, so I have some time to get caught up on my things that I can hopefully finally get all my back work done here. And I appreciate everyone's patience on that. I really do. Okay, let's go and take a look at the last problem. As promised, just one integration problem. I'm going to really focus the integration more toward the final when we had a chance to, work with the integration more thoroughly. Okay, so, but we'll go ahead and take a look at the integration of this. It's fairly straightforward integration type problem. So let's walk through this now. If I want to integrate this, this is an indefinite integral. I mean, all we have to, oh, you know what? I just occurred to me. I don't think we've done, I got a comment here. Let me see what this is. Oh, what assignments are going to be moved up? Someone asked the question. It's basically going to be the assignments that were all the assignments that were due after test one. I want to give everyone to the end of the semester to kind of work on everything. So I'm gonna move up the dates, you know, to like mid-December. One thing that, so I'm working, hold on, system I'm working with. In working, I'm sorry guys, I'm blanking on the system, Wiley. In working with Wiley, you're allowed to set a homework date, but it doesn't allow students to, let's say, work past it without, you know, work past the date. They just give you an option of the date and that's it. So I will extend those deadlines. I'll try to do it like sooner than later. Because I know you know, some people maybe want to work on this over the holiday weekend. I don't recommend that, but if you want to, I'll try to make it available sooner than later because I realize those are things that don't take a lot of time necessarily, but they are important to you guys. And once I do that, I will send out an announcement to everybody. What I'll do is, this is one thing I didn't put with this problem, but let me just add the interval from, let's make this from 1 to 4. Because one thing that you did not work with indefinite integral. Let's make this a definite integral. Oh, okay. I had someone asking for this, so here you go. Yeah, bear in mind, everyone, I am planning on posting these videos so you can watch these again over the weekend if you want, to help prepare you for the test. Sure. All right, let's take a look at the last problem then, number 9. It's going to be from 1 to 4 of the quantity of 3x to the 8th minus 7x to the 3rd plus 6 dx. All right. So again, watch how I'm going to do this. Okay, so when I do the integration on a problem like this, I'm going to write this as 3x. I'm going to add 1 to the exponent first. So I add 1 to the exponent, and then I end up dividing by the exponent that I obtain as a result. Okay. So in other words, I just kind of take care of the exponent first, and then I divide by what the exponent is. We're going to simplify this in a moment. All right. Minus, I'll write this as 7x to the 4th. I'm going to divide that by 4. This will be plus 6x. And I'm going to put this now from 1 to 4. Or just like a straight line, I'm going to put 1 to 4. So I'm going to put 4 into this first. And I'm going to put 1 in. So let's see. Ooh. Now, let me make this just, oh, I just saw the size of this exponent here. Let me make this a wee bit smaller. Let me make this a wee bit smaller. I'll make it from 1 to 2. Okay. I'll look at the size of the problem I have. Because this is an indefinite integral, we have to introduce things like C. But I think in a class like yours, they don't really teach indefinite integrals because your class is just about applications. So this is where x is going to equal 2 minus x is going to equal 1. So this would be 3 times 2 to the 9th over 9. And actually, I can take this 3 out and just make this 3 if I reduce that. So let me make that 1 over 3 and simplifying that. Minus 7 over 4. This is going to be 2 to the 4th. Oh God, I really should have started this on a separate piece of paper, but I'll move it up a bit. So I have room to be able to work for this. Plus 6 times 2 squared. Now, that's putting 2 in. When I put 1 in, this is going to give me 1/3 times 1 to the 9th minus 7/4 times 1 to the 4th plus 6 times 1. And it's going to be minus this whole quantity here. So this is a part that can get a little messy sometimes. So I'm going to rewrite this whole thing again. So here I have 2 to the 9th over 3 minus 7/4 2 to the 4th plus 6 times 2 minus the quantity. This could be 1/3 times 1 to the 9th minus 7/4 1 to the 4th plus 6 times 1. So let's see, 2 to the 9th. 2, 4, 8, 16, 32, 64, 128, 256, 512. Okay. So this is going to be 512 divided by 3. 8, 9, so that's not going to work out nicely. This is going to be 2 to the 4th, that's 16. 16 times 7. If I weren't sick, I could do this in my head. Yeah, 112. So this will be 112 divided by 4. That actually probably simplify. Plus 12 minus. This will be 1/3 minus 7/4 plus 6. So I'm gonna stop folding this over now. This is the part where the math of this can get a little messy, especially if you got to work with like common denominators. I'll try to pick a problem like for this kind of work. I'll pick a problem that's not going to be quite this cumbersome. Because if I want to try to get common denominators here, this is going to be 12. Oh God, these are going to be big numbers. So I need this over 12. I need this over 12. I need this over 12. I'm going to multiply these by 4. That's going to give me 2048 over 12. Multiply each of these by 3. That's going to give me 336 over 12. And if I take 12 over 1, I put that over 12. That's going to be plus 144 over 12. Hang on. 2048 minus 336 plus 144. Let me see if I can divide that by 12. Does that come out to be a nice number? It does not. Damn. So this is going to give me 1856 over 12 when I work all that out. Minus, what is this quantity going to be? This is going to be 4 over 12 minus 21 over 12. I'm going to multiply this like over 12, so that's going to be 72 over 12. 4 minus 21 is negative 17. Negative 17 plus 72 minus 17 is going to be 55. So this will be minus 55 over 12. So 1856 minus 55. Oh. And that will be the final answer to that question. Again, for your test, I'll come up with some numbers that aren't going to be so terrible to work with, but the work with fractions is one of the fun things you have to do. Now, if you have something that could, put this in a calculation like in one fell swoop, you can do that. But I'm usually gonna look for the answers as a fraction. This is one of those kind of expectations we have working with calculus. So 1801 divided by 12 is the final answer to this. And I think that is it for your practice test here. Are there any questions here?